In contrast to our last graph, the plus 2 was to the output value. Well, now we're adding 2 to the x value. And try to think of, when we talk about the output, is my y, hence why I went up and down. Now we're adding 2 to the x. Well, the x is my left-right variable. If I want to look at, again, my parent function, 3 to the power of x. Sketch the graph. Goes through 0, 1, because anything to the 0 power is still 1. Exponential growth. Asymptote. The same way as before, because any number I plug in there that's positive is going to make it extremely large extremely quickly. Any number I put in there is going to be negative, is going to make it reciprocal, but it'll still never be 0 and it'll still never be negative. What's going to happen is, and it's kind of weird what I call this, is it is my left and right variable, but what I call it is the opposite. And if you go back and look at the table, you'll see why, because adding 2 to the x is actually moving it 2 values to the left. What you would want to say here is everything is going to go to the left 2 units. Left 2, left 2, left 2. Even these ones over here, and it's going to look strange because they're already so flat. Moving them left 2, it's going to hardly look different at all. It's just going to be that graph moves straight over to the left. Now, for our next graph, similarly, if f of x equals 3 to the power of x minus 4, always think of this. Whenever it's attached to that x, well, the x value is left-right. That's going to make it go left-right. On the other one, when it was attached to the y, that makes it go up-down. Well, now it's the opposite, where when we see minus of the x, we think it should be left. This is actually going to make it go right 4 units. Think about it as the opposite of what we would expect. The opposite direction, but also think of that as the opposite number. Where my parent function would start at 0, 1. Well, now I go 4 units right. It's going to start at 4. Now, it's still going to have that exponential growth. It's still going to have that flatten out asymptote effect. And once again, these are the 2 graphs. What's going to be nice is these are all going to be matching. All you have to do is decide whether it goes left, right, or up, down based on whether it's applying to the x or applying to the output. Then we want to say if it goes positive, it'll go up, negative, it'll go down. But with our left, right, if it's positive, it's the opposite. Where we think it'll go right, it goes left. If it's negative with the x, where we think negative should be left, it's going to go right. These are, again, just pairing up. These problems will be very quick for the matching, but just know which direction each variable and each sign is going to take you.